consider reviewing our past lesson. So last time, we mentioned that we do have actually two division of statistics, the descriptive statistics, and the next one is the inferential statistics. So for descriptive statistics, we analyzed our data using frequency count and percent distribution. But the problem with using frequency count and percent distribution is that it cannot give you a summary data that will describe your data, and thus there's the need to use measures of central tendency. However, if you're going to use the measures of central tendency, it means that you also need to consider the nature of your data, whether it is nominal, ordinal, or at least interval. And also, we can also use measures of variation just in case that we have equal value of measures of central tendency and we want to know which of the following data is more spread or less spread. So measures of variation is a measure of the spread. So we can identify whether the data is less spread or more spread or less varied or more varied. And the standard measures of variation is the standard deviation or the variance. And of course, just to review, the main objective of using descriptive statistics is to make or to give description. Now, let us move to the inferential statistics. For inferential statistics, our main objective is to make predictions or inferences based on the analysis and interpretation. And if we want, for example, to determine the significant difference between our variables when grouped according to, or our measurement when grouped according to profile variables. So it is a test, we're going to use test for comparison. So that's the question that asks for significant difference. While if we also want to know if variable A is correlated with variable B, so that is test for correlations or relationships. Or if we want to know if there is a significant influence, if the variable significantly influence another variable, or if some of these variables are significant predictors or indicator, this can also be solved using inferential statistics. But we have to consider, before we will decide what to use, we need to consider the problem, the nature of the data. So that is saying now, what is the shape of the distribution? Is it normally distributed or it is skewed? Or what is the level of measurement? We also need to consider the number of variables involved. So it can be only one variable, we call that as univariate, or if it is two variables, it is bivariate, or three or more variables, that is called multivariate. So let's consider the first purpose. So if our purpose now is comparison, we have to choose between two inferential statistics tests. We have what we call as the parametric test, and the other one is the non-parametric test. So how will we know that we're going to use parametric tests compared with non-parametric tests? So parametric test is actually more powerful than non-parametric test. If our data now is at least interval, so which means it's interval or ratio, and it is normally distributed, then appropriate test is parametric test. While if our data is ordinal or nominal, we do not need to check the normality anymore. it is not qualified for parametric test, obviously because our condition here is it is at this interval, then we're going to use non-parametric test. But just in case that we did not meet the condition for at this interval, or even if our data is at this interval but we did not meet the condition or normality, then this is again the reason why we cannot use parametric. So we're going to use non-parametric test. Let us consider the different parametric and non-parametric tests to compare now our variables. So we can either use, if our concern is to compare our sample mean to population mean, so we will use t-test for one sample. So this is comparison between sample mean and population mean. So if we did not meet the condition for normality, then we're going to use one sample Wilcoxon test. So we have here the list. So we have the t-test for one sample. Counterpart is one sample Wilcoxon test. T-test for independent samples. So this is comparison of two means of independent groups. And if we failed to, again, to meet the condition, then we're going to use Mann-Whitney U-test. So for t-test for dependent samples or paired sample t-test, this is when we have two means, but these two means are correlated. So that's the time you're going to use t-test for dependent samples or paired sample t-test. This is usually used for action research or questions that deals with pre-test and post-test. So you have diagnostic test and assessment test. And then the counterpart, just in case, again, you did not meet the condition for normality, you're going to use Wilcoxon signed rank test. So for t-test for independent samples, it means that this is only limited into two groups because it's comparison of two means. While if you have now more than two, then in its independent group, you're going to use one-way Anova. So equal variances assumed is another condition now that you need to consider when you use this. So aside from the data is at this interval, the data is normally distributed, you also need to consider the test of homogeneity, which shows that there is equal variances assumed. Just in case that you did not meet this condition, so the counterpart of one-way Anova is the Brown foresight. So this is used when equal variances is not assumed. So this is, as mentioned, test for homogeneity. So if significant, it requires for further tests. If the result for ANOVA is significant, it requires for further tests. So that is what we call as post hoc. And we have post hoc tests for equal variances assumed, such as Bonferroni, Duncan, Chaffee test. And we also have post tests for equal variances not assumed, like Tamhane. So let us consider the counterpart of one-way ANOVA. The counterpart is Kruskal-Wallis. So in case that your data is ordinal, and you're going to compare now when group according to 3 or more groups, then you're going to use Kruskal-Wallis. Or just in case, again, you did not meet the condition of normality, then you're going to use Kruskal-Wallis. There is also counterpart for the post post hoc test, and that is called pairwise comparison test and non-parametric test. And for t-test for dependent samples, so we have only two correlated means. So if we have now 3 or more, then we're not going to use t-test for dependent samples, but we will use repeated measures, Anova. And the counterpart in non-parametric is the Prideman test. So as you can see, there is a strict conditions for you to come up or for you to use the test. For example, if you want to determine if there is a significant difference between 3 samples and it is normally distributed, it is at least interval, can you use the test for independent samples? What do you think? Okay, so actually, by looking into this discussion, so as mentioned, we're going to use t-test for independent samples if it's only limited into 2. But if not, we're going to use one-way ANOVA. It is possible to use t-test for independent samples for 3 groups, but you have to do it thrice. Wherein, let's say you're going to compare A compared with B, A compared with C, and B compared with C. So you're going to do the t-test for independent sample 3 times. Not unlike if you're going to use one-way ANOVA. So you just need to use one-way ANOVA. And in case there is a significant difference, you have to use the post hoc test. Okay, so in our next video, we will consider t-test for example of t-test for 1 sample. And let's also try to use 1 sample Wilcoxon test, which is its counterpart.